Okay, so now the exercises related to these relations. The first exercise, which is almost all of these exercises are important for understanding the concept, so we cannot really skip any of them. So let's go through them one by one. If the mosquitoes allow us. So you have let A be equal to basically 1, 2, 3 and so on, all the way up to 14. You want to define a relation R from A to A. Define a relation R from A to A by R is equal to, for example, all ordered pairs x comma y such that 3x minus y is equal to 0, and where x and y belong to the set A. And write down the domain, the codomain and the range. Okay, so now to solve this problem, so you know that basically a relation R from A to A is basically by this definition or rule, basically would be a subset of the set A times A. So the set A times A would be basically would be a set basically having all of these ordered pairs like 1, 1, 1, 2, and so on and so forth, all the way up to 14, 14, for example. 14, 14. And that would be the number of terms would be basically would be 14 squared pairs. Now if that's the case, then basically now you need to take a subset of A times A, and that becomes the So now you need to basically find the subset of A times A, which becomes the relation A, the relation R. And this relation R is from A to A, of course. This is A times A. Where you have this sort of relationship between X and Y, meaning that basically 3x minus y is equal to 0, or basically you can say that your y is equal to 3x. If you rewrite this expression, you'll get y is equal to 3x. That means that the second component over here is 3 times the first component. It's 3 times the first component. So now in order to find out what members this set is going to have, basically you need to do a simple, you need to do a simple experiment, meaning that so for example, if you choose, for example, if I write r over here, if I choose, for example, 1,3, so 1,3, you can see that over here y is equal to 3 times x. 3 times 1 is equal to 3. So that's basically one thing over here. And since a goes from, for example, 1 to 14, 1, 1, 1, 2, 1, 3, and so on and so forth, all the way up to 1, 14. So you see, when you start from 1, you will have 1, 1, you will have 1, 2, you will have 1, 3, and all the way up to 1, 14. You will have that, and the only pair that can be used here is basically this one, which is basically 1, 3, because then 3 is equal to 3 is equal to 3 times 1, which is basically the rule over here. And then in the second, basically in the second round, you need to start from basically your pair, the sets that you have are basically A, which is basically 1, 2, 3, and all the way up to 14. And then again you have another set, the same set, A is equal to again 1, 2, 3, all the way up to 14. And now you basically want to calculate the A times A, which is basically 1, 1, 1, 2, 1, 3, and so on, all the way up to 1, 14. Then you will start with 2, and then you will start with 3 with all of these numbers, 4 with all of these numbers, and so on and so forth. So what that means is that then you will have basically, for example, 2, 1, 2, 1, for example, 2, 2, 2, 3, and so on and so forth, all the way up to 2, 14. And over here again, you need to pick the one in which y is equal to 3x. So 6 and 2 would be basically 2, 6 over here would be the one that we need, because 6 is equal to 3 times 2. So then the next one is 2, 6 over here. Now the next one that, for example, we can pick from here is 3, 1, and then we have 3, 2, and then we have 3, 3, and then all the way up to 3, 14. And so then basically, for example, 3 times 3 is equal to 9, 3 times 3 is equal to 9, 3 times 3 is equal to 9, so you have to pick 3, 9. Then you need to pick 4, 12. Then you need to pick 5 times 3 is equal to 15, which does not exist. So that's all the 4. I mean, you can find only these 4 members of this set. So then I can write 1, 3, 2, 6, then 3, 9, then 4, 12, and that is basically the relation that we were looking for. We were looking for this relation on A, basically from A to A, or you can say on A, where basically r is equal to x, y, where 3x minus y is equal to 0, and x and y both belong to A. And now you want to write the codomain, the domain, and the range of this relation. Now, basically, to write the domain of the relation, you can write the domain is equal to basically the domain of R, of course. The domain of R is equal to 1, 2, 3, and 4. 1, 2, 3, and 4. And the range of R, is basically okay. So then the range of R is basically you can basically again use these numbers over here. For example, 3, 6, 9, and 12. So that's again, you can use these numbers and you would have no problem with that. But then to find the codomain of R, what you need to do is basically, the codomain of R is basically, you know that R is a relation from A to A. Basically. So then the codomain of this relation is going to be the set A. So which is basically 1, 2, 3, and all the way up to 14, which is the set A basically. So that is basically how you would solve this problem. 2, 2, 1, 3, 2, 6, 3, 9, 4, 12. The domain is 1, 2, 3, 4. The range is 3, 6, 9, 12. And the codomain is 1 through 14. So that is the answer is correct. There is no problem with the answer. Okay, so that is that. Okay, so the next question that we have is define a relation R on the set N of natural numbers. So you define a relation R on the set N of natural numbers, on the set N being the natural numbers, by basically R is equal to the set of all x comma y, such that y is equal to x plus 5 and x is a natural number less than 4. X is a natural number less than 4, and also x and y belong to N, and depict this relationship using roster form. And write down the domain and range. Write down the domain and range. Okay, so basically what we want to do is we want to define a relation. We want to define a relation R on the set N of natural numbers by this rule, which is basically R is equal to basically all the ordered pairs, basically x comma y, such that y is equal to x plus 5, and x is a natural number less than 4, So you have basically so R is going to be equal to basically 1 comma and 1 plus 5 is equal to 6, and then you have basically 2 comma 7, you have 3 comma 8, and you have, that's it, less than 4. And this is the raster form. This is the raster form. Now the domain of R is equal to 1, 2, and 3, and the range of R is equal to 6, 7, and 8. That's the answer. So number 2, 1, 6, 2, 7, 3, 8. Domain is 1, 2, 3, 6, 7, 8. So that's the answer there. Another question. 339. 339. So A is basically this set over here, 1, 2, 3, 5. A is a set of natural numbers 1, 2, 3, and 5. And B is this set, which is 4, 6, and 9. 4, 6, and 9. I want to define a relation R from A to B. You want to define a relation R from A to B by R is equal to x comma y, such that the difference between x and y is odd. The difference between x and y is odd, and x belongs to A, y belongs to B. X belongs to A and y belongs to B. Write R in raster form. Write R in raster form. Okay, so you have your A basically and B over here. You want to define a relation R from A to B in such that basically R is equal to the x comma y, such that the difference between x and y is odd. That means that, for example, if I write my x and y as, for example, I could write my x and y as 1 comma 4, then 1 comma 6, and then 1 comma 9, and then you can write, I can write, for example, 2 comma 4, 2 comma 6, 2 comma 6, and then 2 comma 9, and then you just keep going until I get to 5 comma 4, all the way up to 5 comma 9. Now over here the difference has to be odd, meaning that now if the difference of two numbers has to be odd, those two numbers have to be, for example, let's say that Let's try two odd numbers, for example 3 and 5. So 5 minus 3 is equal to 2. It's an even number. If I take one of the numbers as a for example 2 and one of the numbers as an odd number, then 3 minus 2 is going to be equal to 1. That means that the number is going to be an odd number. Or to do one more case over here, for example, I take 4 and 5. Then 5 minus 4 is equal to 1, an odd number. To do one more example here, for example, I take 2 and instead of 3 I take 5, for example. Then 5 minus 2 is equal to 3, which is an odd number. So that means that if one of the numbers is even, one of the numbers is odd, the difference is going to be odd. So if one of the numbers is even, one of the numbers is odd, the difference is going to be odd. The difference is going to be odd. Now if both the numbers are odd, the difference is going to be even, which is not what we are looking for. And if both the numbers are basically, if I said that if I had, for example, 2 and 4, 4 minus 2 equal to 2 is even. 2 and 6 is even. So both even would be even. Both odd would be 3 and 5 would be again even. So one of them has to be even, one of them has to be odd. So what that means is that from all of these sets, I can take, for example, 1 and 4, 1 and 6, and 1 and I can take these two, because if I take this one, for example, 9 is an odd number and 1 is already an odd number, so this is odd even, this is odd even. So I can take 1 comma 4, I can take 1 comma 6, over here I can take 2 comma, for example, 2 comma 9, over here I can take 3 comma 4, for example, 3 comma 6, 3 comma 6, but 3 comma 9 I cannot take, because then both of them would be odd. So 1, 2, and 3, and 5. So 5 would be 5 comma 4 I can take, 5 comma 6 I can take, but 5 comma 9 I cannot take. So this is basically the members of R. So then I can write R is equal to basically 1 comma 4, 1 comma 6, 2 comma, what is this? 2 comma 9, 2 comma 9, 3 comma 4, 3 comma 6, 5 comma 4, 5 comma 6. So that's basically the set R in raster 4. And that's it. That's basically the answer. So let me check the answer over here. Number 3 is 1, 2, 3, 4, 5, 6, 7. Okay, 1 comma 4, 1 comma 6, 2 comma 9, 3, 4, 3, 6, 5, 4, 5, 6. The answer is correct. Okay. So the next question that we have is, for example, there is a figure over here. There is a figure over here, and in this figure we have, it shows a relationship between two sets P and Q. So we have basically 5, 6, and 7, and 3, 4, and 5. I have this set and this set over here, so this is mapped to this is mapped to this, and this is mapped to this. This set is P, this set is Q. Now, so this basically shows a relationship between the sets P and Q. You want to write this relation in set builder form and in raster form. And what is its domain and range, basically? Domain and range. Okay. So in raster form, this relationship is, if I call the relation, for example, R, I can say R is equal to, for example, 5, 3, 6, 4, and 7, 5. So you can see that if I call this, for example, X, and if I call this Y, you can see that Y is equal to X minus 2. 5 minus 2 is 3, 6 minus 2 is equal to 4, 7 minus 2 is equal to 5. So I can write this relationship as, or this relation as R is equal to basically all ordered pairs X, Y, such that Y is equal to X minus 2, and X belongs to P, and basically Y belongs to Q. Okay. So this is raster form, and this is set builder form. And the domain of R is basically 5, 6, 7, 5, 6, 7, and the range of R is 3, 4, and 5. So the answer to number 4, R is equal to X, Y, such that Y is equal to X minus 2, 4, X is equal to 5, 6, and 7. Okay, so here I've written X belongs to P and Y belongs to Q, but then they have written this part as basically for X is equal to 5, 6, and 7. So that way, you know, basically this is a better condition than this, because there could be some sort of confusion over here, but this way there is no way to be confused about this statement. And of course, when I wrote this, I did think about it, and there was actually no problem with it, but it's not a very clear state. It's not an ambiguous statement, but it's not a very clear statement either, meaning that if you told this to someone, they would have to just keep searching and putting these pairs together. But this way you already know, for example, your X's are basically these three numbers, and then subtract 2 from each of them, and you will get the other set over here. And that's basically that. Now number 5. Number 5 is let A be equal to 1, 2, 3, 4, 6. Let A be equal to 1, 2, 3, 4, and 6. And let R be the relation on A. Let R be the relation on A. Defined by A comma B, such that A and B belong to A, and B is exactly divisible by A. Is exactly divisible by A. Now you want to write R in raster form. Write R in raster form. Find the domain of R. And find the range of R. Okay, so now R is a relation on A, meaning that when you say R is a relation on A, what that means is that basically R is a relation from A to A, defined by this rule over here. And you want to write R in raster form. So if you write, basically if you calculate basically A times A, or the Cartesian product of A by A, you will get 1, 2, and then 1, 3, and then 1, 4, and so on and so forth, all the way up to 1, 6. 1, 6. And then you come all the way up to 6, 1. You come all the way up to 6, 1, and go all the way up to 6, 6. Now, the condition over here is that B has to be divisible by A, meaning that, for example, in all of these cases, all of these B's are divisible by A, for example, because A is 1, so any number is divisible by 1. So then you can say that, for example, your R is going to be equal to all of these, basically 1, 2, 1, 2, 1, 3, 1, 4, 1, 6. 1, 4, and 1, 6. Then you have 2, basically 1, for example, 2, 1, 2, 2, 2, 3, 2, 3, 2, 4, and 2, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 1 is also there. I forgot 1, 1 here. 1, 1 is also there. Okay, so now basically only this case, for example, 2, 2, because 2 is divisible by 2, and 2, 4 is also right, and 6 comma 2 is also right. Now when it comes to 3, for example, it's easier to write them out really. That way you wouldn't make any mistakes. So 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 1, 2, 3, 4, and 3 comma 6. So this one and this one. So you have 3 comma 3 and 3 comma 6. And then the next one is 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 4, and 4 comma 6. I'm not sure if we should actually see the definition for divisibility, but I'm not really sure if that would be, for example, that would be if 2 is, I don't know if you can say whether 2 is divisible by 4 or not. We have to look that up, but then basically let's see what that is. When one number can be divided by another number with no remainder, we say the first number is divisible by the other number. For example, 20 is divisible by 4. If a number is divisible by another number, it's also a multiple of that number. For example, 20 is divisible by 4, and so 20 is a multiple of 4. Okay. So for example, in this case, if I divide 2 by 4, I will get 1/2, remainder 0. So I suppose this is divisible. I'm not sure if, but of course 2 is not a multiple of 4, because you could say that 4 is a multiple of 2, but 2 is not a multiple of 4. But on the other hand, for example, 4 and 4, 4 is divisible by 4. 4 divided by 4 is equal to 1. You will get a natural number here, and the remainder 0. Or over here, you would again get a fraction. For example, 6 divided by 4 is 3/2. Remainder 0, for example. We will have to see about these. For example, I don't think I really don't think so, but 4 comma 2 and let's see, for example 4 comma 6, we will check whether they are in the answers or not. But I know that 4 comma 4 is the answer actually. Okay. Now 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, and 6 comma 6. Well, I would say this would go into this category again. 6 comma 2, for example. Well, that goes into this category as well, but 6 comma 6 is definitely there. So now let me take a look at the answer. See what the answer is. Number 5 is 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6, 2 comma 2, 2, 4, 2, 2, 2, 4, 2, 6, 2, 2, 4, 4, 6, 6, 3, 3, and 3, 6. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so these are not a part of the answer. And there is a word over here that says exactly divisible. I don't really know if, what is really meant by it. But anyway, the answer is basically this is the right answer there. And now we will see about the rest of the problem. We will have to see about that in the, I don't know. Anyway, not important really right now. So now if you want to write R in raster form, this is the raster form, and then basically the domain of R would be the domain of R would be basically 1, 1, 2, 3, 4, 6. 1, 2, 3, 4, and 6. I'm not repeating anything here, as you can see. And the range of R, is 2, 3, 4, 6, 1. So 2, 3, 4, 6, 1. 2, 3, 4, 6, 1. 2, 4, 2, 3, 6, 4, and 6. So 1, 2, 3, 4, 6. 1, 2, 3, 4, and 6. That is the range, and the 1, 2, 3, 4, 6. 1, 2, 3, 4, 6. That's number 5, and this is the right answer. Okay. So number 6 is, okay, so we have a couple more questions here. For example, we have determined the domain and range of the relation R defined by, you want to determine the domain and range of R defined by R is equal to, for example, x, x plus 5, where such that x belongs to this set 0, 1, 2, 3, 4, and 5. So you can see that you can define your R in this way as well, meaning that you can, instead of y, for example, you can write x plus 5, and then over here you can write, for example, x belongs to this set, and then that's basically how you define your R. Now you can see that your R is going to be for example, 0 plus 5 is 5, 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9, and 5 plus 5 is 10. And so your domain is basically 0, 1, 2, 3, 4, and 5, and your range is 5, 6, 7, 8, 9, and 10. So that was number 6. Number 6, 1, 2, 3, 1, 2, 3, 4, 5, 7, 8, 9, 10. Okay. Number 7 is write that relation R is equal to basically x comma x cube x cube, x is a prime number less than 10, such that x is a prime number less than 10, and you want to write R in raster form. So the prime numbers are starting from 1. So basically you know that the prime number is basically a number that has basically two factors, 1 and itself, meaning that, for example, 3 is a prime number. 3, you can write it as 1 times 3. 5 is a prime number, you can write it as 1 times 5. 7 is a prime number, 1 times 7, but 1 is not a prime number, because you can write 1 as 1 times 1 and both would be 1. So it has to be 1 and basically the number itself and some other number, and so 1 is not a prime number. 3, 5, 7, and of course 9 is not a prime number. 9 is a composite number. For example, you can write it as 3 times 3. So the prime numbers less than 10 would be 3, 5, and 7. 3, 5, and 7. So then 3, 5, and 7. So then you can write your R as basically x would be, for example, 3, and 3 cubed is equal to 27. And for example, 5 cubed is equal to 125. And 7 cubed is equal to 49 times 7 is equal to 63. 28 plus 6 is equal to 34. 343. So then your R in raster form would be, for example, this set over here. Number 7 is, 2 is also a prime number, I'm sorry. 2 is also a prime number. 2, 3, 5, 7. So you can write this as 2, 8 as well. 2, 8. 2 cubed is equal to 8. So that's basically, for example, the answer there. Number 8 is, let A be x, y, z. Let A be x, y, z, and B be, and the set B be basically 1 and 2. Find the number of relations from A to B. Find the number of relations find the number of relations from A to B. Okay, so the number of relations from A to B is basically, you know that the number of relations depends on the number of, when you want to find the number of relations from A to B, what you need to do first is basically find A times B. A times B is going to be, for example, x comma 1 and x comma 2, and for example y comma 1, and so on all the way up to z comma 2, for example. These are all the members of this set A times B. Now the number of all of these elements is going to be 3 times 2, which is equal to 6. 6 pairs. 6 pairs. And of course, you see over here, n of A is equal to 3, and n of B is equal to 2. Now n of A times B is equal to n of A times n of B, which is equal to 3 times 2, which is equal to 6. The same number over here. Now the number of relations, now this is important, of course. The total number of relations from A to B, you can, another way of saying the same thing is basically you could say that number of all possible subsets of A times B. And you can find that number by raising 2. You can find that number by raising 2 to this number, which is basically raising 2 to this number n of A times B, which is equal to 2 raised to the power 6, which is equal to 64. That is 64. So that is that. Now question number 9 is, let R be the relation on Z. Let R be the relation on Z. Z is the set of integers defined by R is equal to all the order set pairs A and B, such that A and B belongs to the set of integers, and A minus B is an integer. And you want to find the domain and range of R. Okay. So over here, so if R is the relation on Z, meaning that you have the set of integers, and the set of integers, and the set of integers goes to set of integers, and that is R. So you can imagine that you have all of these ordered pairs going from every member of the set of integers to every other member of the set of integers, and even to that member itself in the other set. That is basically R. And of course you know that Z is basically 0, 1, 2, 3, and so on and so forth, all the way to infinity, -1, -2, -3, all the way up to -infinity. That is that. Now, this is the set of integers. Now, R is a relation defined on this this is basically Z times Z, of course. This is Z times Z, or the Cartesian product of Z and Z. So R is a relation defined on this set, or you can say R is a subset of this set, defined by this, meaning that you have all the ordered pairs, basically A comma B, such that A and B belong to the set of integers, and then A minus B is an integer. A minus B is an integer. So that means that, for example, that means that basically you know that the set of integers, is closed under subtraction, meaning that you take any number from the set of integers and you subtract from that any other number from the set of integers, and the result is going to be some number from the set of integers. For example, you take 2 and subtract from it, for example, 5. You'll get -3, which is again some number from the set of integers. That means that your domain can be any basically integer, your range can be any integer, and so what that means is that the domain of R is going to be Z, the set of integers, and your range is going to be Z, the set of integers. That's basically your answer. So number 9, the domain of R and range of R is basically both the set of integers. Okay, so we are done with this, with these examples, and these were of course necessary and important, all of them. Now the next thing that we have here is basically we finally got to functions, which we will we will continue in the next video. So I'll see you in the next video with functions, and thank you. Okay.